Chem lab, we began an experiment in which we were crystallizing potassium aluminum sulfate dodecahydrate, also known simply as alum. To do this, we extracted alum from aluminum foil. To begin the experiment, we took a piece of aluminum foil and we dissolved it in KOH, or potassium hydroxide solution. This was a necessary step in order to separate the alum in the aluminum foil from many of the foil's other impurities. The alum was soluble, while the impurities were precipitates that were easily removed through vacuum filtration. Next, we added sulfuric acid to our solution. While at first the aluminum hydroxide precipitated out and was visible in the beaker, adding more sulfuric acid in addition to some heat and stirring motion caused the solid hydroxide to dissolve again. At this point, both the desired product, the alum, as well as the impurities from the aluminum foil were soluble and dissolved in the solution. Finally, we put the beaker of our solution into an ice bath. This temperature decrease was the crux of our experiment. Because the alum is insoluble at lower temperatures, while the impurities are still soluble, the alum precipitated out while the impurities stayed dissolved. We used a simple vacuum filter to isolate the solid alum. While the alum product we got was crystalline, the crystals were much too small to see with our own eyes. We thus dissolved as much alum as possible in water to make a saturated solution. As this solution evaporates over time, larger visible crystals of alum will be visible. Unfortunately, 3 days after lab, I'm not seeing any major changes in my alum crystals' growth. As I peer into the vial, it looks pretty much the same as it did on Monday. Just clear liquid. I suspect that not enough liquid has evaporated quite yet to make the crystals visible to the naked eye. I hope this changes soon. Because this lab was pretty awesome, I was thinking about ways I could maybe do this experiment again, at home. Since I don't have any strong chemicals like sulfuric acid and KOH, however, I would have to settle on crystallizing a different substance, possibly sodium chloride. To do this, I would add table salt to a pot of boiling water until it became saturated. I would know when it's saturated when the salt stops dissolving in the liquid and begins to settle on the bottom. When this occurs, I would pour a little of the boiling solution into a clear container, but I would be sure not to let any of the undissolved salt granules go with. Similar to our lab, as the boiled saturated water in the container evaporates over time, larger salt crystals will appear. And if I was feeling pretty fancy at the time, I could add some food coloring in to get colored crystals. One last fun way to grow crystals would be to make rock candy sticks. This process is basically the same process described earlier using sodium chloride. However, this time use sugar rather than salt. Make a saturated solution of boiling water and sugar, and then pour the solution into a mason jar. Insert sticks already covered in a little bit of sugar, and then wait a couple of days and watch your candy sticks transform into rock candy, aka crystals of sugar. Well, that just about wraps up my episode of Alum Crystals, Part 1, The Rise of the Alum. Thanks for watching!